Assalamualaikum warahmatullahi wabarakatuh to my fellow panelists. I would like to introduce myself. My name is Iskandar ROSLI. I am under supervision of Dr. Nur Sabia binti Nasir. In this video, I will be presenting my project on the development of smart walking stick for visually impaired people by using Arduino. In this presentation, I will be covering on the project background, problem statement, objective, and scope of study, literature review, methodology, result and discussion, and lastly, conclusion and recommendation. Project background. Eye vision is one of the most important parts of human physiology and senses. According to WHO, 80% of visual impairment is treatment preventable or treatable. Nevertheless, 39 million people were blind as of 2015, suffering from absolute or almost full vision loss. Due to losing eyesight, these people use white canes or guide dogs to help them to navigate around. However, in Malaysia, the usage of guide dog is wholly not accepted by the community, especially in public areas. Throughout the years, electronic travel aids or ETS have been developed to improve the mobility of the user compared using the conventional aids, which is white cane. ETS include sensors that are able to alert the user to the presence of obstacle through vibration and sound output feedback. The problem statement of ETS they're still using the conventional design of the white cane, which is the long part of the cane and make the device not wearable. Next, most of these ETS are heavy and hard to store away due to number of sensors attached to the device and the unbendable design. The objective of this project are to develop a caneless ETA prototype that can detect obstacles and staircases and alert the user with the corresponding feedback. The scope of the project are to do literature reviews of the developed ETS, create conceptual design and design criteria, and lastly limit the type of input used in this project, which is only measuring the distance compared to other ETS which have light and moisture as the input. Example literature review on the developed ETS. Most of ETS use ultrasonic sensor as a primary sensor to detect the obstacle by measuring the distance between the device and the obstacle. Other sensors such as speed, water, infrared, GSM and GPRS module are added as additional features. This ETS can detect obstacles that are in front of the user easily. However, there are limitations of the ETS such as heavy and difficult to easy storage. Next, I will present the methodology of this project. As shown in figure 3, the first step in this project was to identify the problem, followed by the literature reviews on the developed ETS. After that, I have come up a few conceptual design and system to be made into a prototype. Then, the prototype went through a few testing such as efficiency test, horizontal obstacle, and staircase detection, and lastly, discussion and conclusion on the result of the test. There are three conceptual designs that I have made. Number 1 is based on the design of the forearm crutches. Number 2 is based on the design of bike glove. And number 3 is based on the white cane. The design criteria of the prototype are technical risk, cost, availability of the resources, type of sensor, output feedback, compatibility, and ergonomy. By using path metric, design number 1 had the higher score compared to the other design as shown in table 1. Next, I will explain the proposed system and hardware used in this prototype. Based on figure 6, the system used two SCSR04 ultrasonic sensors as the input to measure the horizontal distance of the obstacle and the distance of the surface to the prototype. The ultrasonic sensor produces wave from the transmitter circuit and collect the reflected wave back to the receiver circuits. Then this data will be processed by the microcontroller, which is Arduino Mega 2560. The microcontroller will calculate the distance and give out feedback according to the threshold condition through the active buzzer. Next, I will present the result of the testing of the prototype. The first test is the efficiency test of the ultrasonic sensor. The ultrasonic sensor HCSR04 sensor are mounted on the breadboard and connected to the Arduino Mega as shown in figure 8. Based on the table 2, at 10 cm and 100 cm, distance the ultrasonic sensor measured 9.6 cm and 100.4 cm with the percentage error of 4% and 0.4% respectively. The efficiency of the ultrasonic sensor to measure distance is high with the highest percentage error of 4%. Hence, the ultrasonic sensor is capable of measuring distance and detecting objects with high accuracy. Next, the result of the horizontal obstacle detection test will be explained. A few boxes are used as obstacle to measure the distance of the obstacle from the top sensor. The boxes are placed at a certain distance from the prototype and given the threshold condition as shown in table 3. The following video demonstrates each of the feedback output. The testing was conducted by a user with a height of 173 cm and the obstacle were placed with distance and height according to the table 5. From the result, it shows the limitation of the obstacle detection of the prototype. The prototype cannot detect any obstacle on the floor up to 50 cm above the floor, but it can detect obstacles that have height higher than 50 cm. Hence, the prototype can only detect obstacles from the knee height of the user. However, this result will be varied with different users since it depends on the height of the user. The following video shows the demonstration of the horizontal obstacle detection test. In the last test, the staircase detection test was held in an indoor environment by the same user with a height of 173 cm. The detection of staircase can be done by determining the difference of the distance between the tip of the sensor and the floor. When the distance between the tip of the sensor and the floor is increased, it's detected as downstairs and vice versa. In this test, the height of each step in the staircase is 20 cm. For the table 5, if the distance between the tip of the sensor and the floor is higher than 95 cm, the prototype will interpret there is a down staircase in front of user and will buzz twice. While If the distance is lower than 75 cm, the prototype will interpret it as up staircase in front of the user and will buzz once. For no staircase situation, the prototype will not give any output feedback to the user. From this test, it shows that prototype is capable of detecting up and down staircases and give out the appropriate feedback to the user. However, the result will be varied with different users since the interpretation of the staircase is dependent on the height of user. Following video is the demonstration of the staircase detection test. Lastly, this project produced a caneless blind stick prototype to assist visually impaired people, which alert the user the upcoming obstacle at a range distance of 50 to 250 cm and staircase detection with a set of appropriate feedback outputs in the form of sound. There are a few feature recommendations that can improve the quality of the prototype. First, change the forearm rest into a strap that can adjust for each person so that each person will have the highest comfortability of the device. Next, use a smaller microcontroller such as Arduino Nano to reduce the size so that the weight of the prototype will be decreased or lighter. Lastly, use speech playback module to give out more accurate and understandable feedback compared than using active buzzer. Thank you so much for your attention throughout this video presentation. Any inquiries, it can be done through contacting me by email or phone listed below. Assalamualaikum warahmatullahi wabarakatuh and have a good day.